Hi everybody. Today we are going to talk about how to calculate the percent composition and the empirical formula and molecular formula of a compound using percent composition. Percent composition is defined as the percent by mass of an element in a compound. We can calculate the percent composition by taking the mass of an element divided by the total mass of the compound and multiply it by 100. Let's take a look at an example. Example number 1. Find the percent composition of carbon dioxide. So we know that the chemical formula for carbon dioxide is CO2. From here, we count how many of each element we have in the compound. We have C and we have O. We have 1 C and 2 O. All right. Then we take a look at the periodic table and see that we have a mass of carbon of 12, so we multiply it by 12, and a mass of oxygen, 16. So we multiply this by 16. This gives us 12 and 32. We add these up. 2 plus 2 gives us 4. 1 plus 3 gives us 4. So we have 44 grams. Then we take the mass of each element divided by the total molar mass. So we take 12 divided by 44, 32 divided by 44, and then we multiply them both by 100. If you plug that into your calculator, then you will have the percent of each element in carbon dioxide. For example number 2, what is the percent hydrogen in glucose? I would like you to try this one on your own. Remember, you're just looking for the percent of hydrogen in this compound. So you do not have to calculate the percent of oxygen and carbon. We can use the percent composition to determine the empirical formula of a compound. First, you determine the percent composition of the compound. Then, assume 100 grams of the compound and change the percent sign to grams. Then, you convert grams to moles using a mole conversion like we've been doing in class. Then divide each by the lowest number of moles, and if any halves exist, multiply by 2 to get it to be a whole number. Let's take a look at an example. A compound is analyzed and found to contain 25.9% nitrogen and 74.1% oxygen. What is the empirical formula for this compound? All right, so we're going to start with our percent composition. In this problem, it's already been given to us, so we do not have to do step 1. So we'll take our first percentage, 25.9% of nitrogen and 74.1% oxygen. All right, so we start with those. Then we can change our percent to grams because we're assuming 100 grams. So we have 25.9 grams of nitrogen and 74.1 grams of oxygen. From here, we will calculate the number of moles. We put it in a bracket, 1 mole on the top, and the number of grams of nitrogen in the bottom, which is going to be 14 grams. Get that from the periodic table. Same thing for oxygen. 1 mole goes in the top right, and in the bottom right, the molar mass of oxygen, which is 16 grams. All right, you need to grab a calculator for this one. So if we plug that in, take 25.9 times 1 divided by 14, that gives us 1.85 moles. For the second one, we take 74.1 divided by 16. That gives us 4.63 moles. All right, our next step tells us that we divide through by the smallest. So we look at both number of moles, and we see that the moles of nitrogen is the smallest. So we divide by 1.85. All right. So that will make this one, and then our second one, we will take 4.63 divided by 1.85, and that gives us 2.5. Since we have a half here, we need to multiply everything through by 2. So we're going to take 1 times 2, which gives us 2, and 2.5 times 2, which gives us 5. These numbers are the subscripts for our equation. We look for the element that is least electronegative, and that's the one that's going to go first. Nitrogen is our least electronegative element, so we plug that in. N, 2 coming from here, O, 5 coming from here. This is our empirical formula. Here's example number 2. A compound has 42.9% carbon and 57.1% oxygen. What is its empirical formula? I would like you to take the time to stop this video and give this one a try on your own. Last but not least, we can also use our percent composition and empirical formulas to calculate the molecular formula of a compound. First, find the molar mass of the empirical formula. Then, take the mass of the molecular formula that's given to you in the problem and divide it by the mass of the empirical formula. Then, take the answer from that and multiply it through all the subscripts in the empirical formula. Give this example a try on your own.